Welcome back for another deep dive. This time, we're tackling AI and math.
Oh, wow. This is going to be interesting.
It really is, and to help us, we've got some incredible insights from a conversation with Dr. Swarat Chutiri.
From UT Austin and Google DeepMind, right?
You got it. And what I find so fascinating is how he steers clear of that whole philosophical debate.
You mean about whether AI can actually reason like we do?
Exactly. Instead, he focuses on what we can actually measure, like how well AI performs on tough math problems,
Yeah.
or writing robust code, or just how efficiently it solves problems.
So looking at concrete results, not getting bogged down in subjective comparisons to human thinking,
Right. And this leads him to this super interesting concept called neural-symbolic programming.
where neural networks and good old-fashioned symbolic code actually team up.
Exactly. And it's proving super powerful, especially in projects like alpha geometry and alpha proof. They're making some serious progress in proving mathematical theorems.
Which makes sense, right? Neural networks are amazing at spotting patterns, learning from tons of data, but they can lack that, precision and logical rigor of symbolic systems.
It's like they each have their strengths and weaknesses.
Yeah, and by combining them, we can really get the best of both worlds.
And it's funny, even systems that seem like pure machine learning often rely on symbolic tools behind the scenes.
Oh, totally. Like those agents that use language models to write code and then run it for feedback.
Right. They still depend on the structure of those programming language interpreters. Python, for example.
It shows how intertwined those approaches really are. And as AI gets more complex, those lines are probably going to blur even more.
Absolutely. Dr. Choudhury uses this project called Dreamcoder as a great example.
Dreamcoder. Tell me about it.
Well, it uses neural networks, but it actually starts with this really basic language called lambda calculus.
Huh. Interesting starting point.
Right. And from there, it learns these higher-level abstractions, essentially bootstrapping its way up to more sophisticated reasoning.
That's amazing. So it's not just applying what it knows, it's actually building new layers of understanding.
Exactly. And this brings up this mind-blowing possibility.
Go on. I'm all ears.
What if AI can discover abstractions that we humans, with all our intuition and experience, haven't even thought of?
Whoa, leading to entirely new forms of math, like math that's beyond our current human understanding.
Exactly. It's like it challenges us to think beyond our own limitations, to embrace this future where AI isn't just a tool, but a partner in discovery.
It's a bit like AI is showing us a new dimension of math we didn't even know existed.
Exactly. It's a wild thought, right?
Right.
And it begs this really fundamental question.
Okay, hit me with it.
If AI can find new mathematical truths, does that change what math even is? Is math something we invent, or is it something we discover?
Whoa, that's getting deep. Like, is AI revealing some fundamental truth about the universe through math?
Right. AI is adding this whole new layer to that age-old debate.
Makes you wonder what mathematicians think about all of this.
Well, Dr. Chadori, and he admits he's not a mathematician himself.
Sure, computer science is a different beast.
He says a good theorem, at least in computer science, often balances two things:
Okay, I'm intrigued. What do things?
the novelty of the idea itself and its connection to real-world problems.
So, it has to be new, but also relevant.
Exactly. He uses the example of algorithmic game theory,
Right, trying to understand those complex dynamics of online interactions.
and that actually emerged from a need to solve practical problems.
So it's like a feedback loop between theory and application. But as we get AI more involved, there are definitely limitations to consider.
Like what? I'm curious.
Well, if an AI system is limited by the tools and tactics we give it, could there be whole mathematical universes it simply can't access?
That's a really interesting point. It's like we might be limiting AI's potential by constraining its tools.
Exactly. It's a reminder that even the most sophisticated AI is still bound by what we humans understand and can program.
So it's about finding that balance, right, between AI's power and our own limitations, making sure we're not overly reliant on it, but viewing it as a tool to augment our own abilities.
Right. It's about this collaborative dance between human and machine using each other's strengths.
I like that. A collaborative dance is a great way to put it.
And we're still learning the steps, but the potential is huge.
Absolutely. And this brings up another fascinating aspect: mathematical creativity. Can AI be truly creative, or is it just remixing what it's learned?
That's the million-dollar question, isn't it? Can AI truly think outside the box?
Dr. Chaudhuri says there's this tension, this push and pull.
Between relying on existing knowledge, which can be efficient, and needing to break free from those constraints for genuine creative leaps.
It's a tough one. But Dr. Chaudhuri points to the work of Miles Cranmer on symbolic regression.
I'm not familiar with that. What's the idea?
It's about using data as a grounding mechanism for AI creativity, like finding mathematical expressions that fit a given data set.
So it's like using real-world data to make sure AI's ideas are both testable and, relevant to the real world?
Right. It's like a reality check for AI's creative explorations. But even with that, the question remains, can AI reach the same level of creativity as us humans?
It's a tough one. Maybe it's not about a yes or no answer.
Maybe it's more of a spectrum.
Yeah, like different types of creativity with AI occupying a space that complements ours. It's something we'll continue to explore as AI evolves. And as this field develops, it really makes you think, doesn't it?
Yeah.
Different kinds of creativity.
It does. And speaking of creativity, what excites you most about the potential of AI for math?
Honestly, This whole idea of AI acting as a co-pilot for mathematicians.
Dr. Shohuri talks about that.
He does, and he even mentions Terence Tao's prediction.
That we'll have AI co-pilots for math by 2026.
Right, that's just around the corner. Makes you wonder what they'd actually do.
Imagine AI that can sift through massive databases, instantly finding relevant lemmas and proofs.
Wow, think of the time that would save.
Exactly. And breaking down complex proofs into smaller chunks, making collaboration so much easier.
It'd revolutionize how research is done, and maybe even make advanced math more accessible to more people.
Absolutely. And then there's the possibility of AI discovering entirely new concepts, opening up areas we haven't even thought of.
It's like having an AI explorer charting unknown mathematical territory.
Exactly. But it does raise some questions, like how would this change peer review?
Right. Would we trust an AI to validate a proof?
And what would it even mean for a proof to be considered elegant or interesting in this new world?
Would our sense of mathematical beauty change if it was AI shaping the landscape?
Those are great questions. And it leads us to Dr. Shohuri's own work. He's developed a system called COPRA.
COPRA? I haven't heard of that one.
Well, it uses a large language model to suggest tactics for proving theorems.
Oh, so like a guide for mathematicians.
Exactly. But it works within something called the lean proof assistant.
Okay, for those of us not familiar with that, what is it?
A proof assistant is basically software that helps formalize proofs.
Ensuring their logical rigor, like a spell checker for math arguments.
You got it. COPRA uses a large language model, similar to the tech behind ChatGPT, to analyze a theorem.
And then suggest strategies for proving it.
Right. So it's not generating the proofs itself. It's more like offering guidance along the way.
Like a superpowered research assistant. And it's especially effective with models like GPT-4. But I remember earlier you mentioned test set contamination.
Yes. Dr. Shohuri brought that up as a challenge.
Can you remind me what that is?
It's when an AI has been accidentally exposed to the data it's being tested on.
Oh, right. Like it could solve things based on memory, not true understanding.
Exactly. So it's about making sure these systems are truly pushing the boundary.
And not just spitting back what they've already seen.
Exactly. To address that, researchers are developing better evaluation methods.
Like synthetic benchmarks.
Right. Designed to be unlike anything the AI has encountered before. But let's shift gears a bit.
Okay, where are we headed?
Dr. Shohuri also talked about abstraction. Its importance for AI to be robust and generalize well.
Abstraction, that's a fundamental concept.
It is. It's like the ability to extract the essential elements from a complex situation, represent them in a simpler, more generalizable way.
Right, like how we move from counting specific things to understanding the concept of number.
Perfect example.
Okay.
And this ability is crucial for AI to handle new situations, adapt to changes.
Dr. Shohuri uses Dreamcoder, right? As an example of AI learning higher level abstraction.
Exactly. It starts with a very basic language and builds up from there.
Like building a tower with Legos.
I like that analogy. And what's amazing is this raises the possibility of AI finding abstractions we haven't even thought of.
Wow, mind-blowing. It's like AI could help us see the world and math in entirely new ways.
Absolutely. But it's early days. We're still exploring what's possible, but there are definite ethical implications to consider as well.
Oh, for sure. As AI gets more sophisticated, it's vital to develop these technologies responsibly.
Right. Like being aware of potential biases. If AI is trained on biased data, it can perpetuate and even amplify those biases, leading to unfair outcomes.
Absolutely. And then there's the potential for job displacement.
As AI automates tasks, it could lead to job losses. We need to be thinking about how to prepare for those changes and make sure AI benefits everyone.
It's not just about the tech itself, it's about the human impact. And having these conversations is key as we move forward.
Absolutely. Now, going back to Dr. Shohuri's work, he mentioned this concept of linkiness in AI.
Leakiness. Okay, that's a new one. What do you mean by that?
It's about how the level of abstraction we choose can affect reliability and certainty.
I see. So like if an AI system relies on really specific details.
It might be very precise, but also very brittle.
Right. A small change throws everything off, whereas a higher level of abstraction might be more robust, able to handle variations.
But maybe less precise in its predictions.
So it's a trade-off. Resolution versus generalization.
Exactly. And what's interesting is that the level of abstraction we choose is often limited by what we humans can understand.
Right. We're imposing our own limitations on AI because we need to make sense of its outputs. But what if we could let go of that? Let AI explore at levels we can't even grasp.
That's a wild thought.
Yeah.
But then how do we validate it?
Yeah.
Trust it?
Yeah.
If it's operating at a level we don't even comprehend.
Exactly. It challenges our whole approach to knowledge and discovery. It's a question mathematicians and philosophers are wrestling with right now.
And speaking of discovery, Dr. Chaudhuri mentioned AI's potential in other fields too, like physics and biology.
Oh, absolutely. AI can analyze those massive data sets from experiments, helping researchers find patterns and anomalies.
So it's not just about crunching numbers, it's about finding connections regardless of the field.
Right. And AI can spot connections we might miss because of the sheer volume and complexity of data. It's like AI is expanding our own cognitive abilities.
Giving us new lenses to view reality.
I like that. New lenses. And as AI gets more sophisticated, we'll see more of this cross-disciplinary discovery.
It's exciting. Now, to circle back, you mentioned COPRA using a large language model to help generate proofs.
Yes, it's a really interesting approach.
Can you explain that in a bit more detail, how it actually works?
Okay, so imagine you're trying to prove a theorem. You start with the statement you want to prove and some basic axioms. The process is about applying logical steps, called tactics, to transform the statement into something verifiably true.
Like a game of logic.
Exactly. And Cooper uses the large language model to suggest tactics based on where you are in the proof.
So it's not doing the proving itself, but more like offering guidance.
Right. Think of it as a very knowledgeable assistant, but one that can sift through huge amounts of mathematical data, finding things even experts might miss.
Again, there's that issue of test set contamination.
Right. How do we know it's not just regurgitating proofs it's already seen?
Good point.
Researchers are working on that, developing more sophisticated evaluation methods, synthetic benchmarks.
To ensure these systems are making genuine contributions to the field.
Exactly. But there's another challenge, too.
Oh.
The way we represent mathematical knowledge. Traditional notation with all its symbols can be hard for AI to process.
Like trying to teach a computer to read sheet music without music theory.
Perfect analogy. So researchers are developing new languages and representations that are more AI-friendly.
It's not just about the AI, it's about how we communicate with it.
Exactly. And maybe this is where neural-symbolic programming comes in, combining neural networks with symbolic systems.
Creating AI that can understand math more like we do.
Right. Which brings us back to that fundamental question. What does it mean for AI to understand math? Is it just manipulating symbols? Or is there something more?
It's a deep question. Maybe one without a clear answer for a while.
But as AI gets more advanced, it's a question we need to keep asking. It forces us to think about what it means to think, to reason.
It's almost like AI is forcing us to examine what it means to be human. Pretty powerful stuff.
It is. And as we develop these powerful tools, it's crucial to do so with humility.
Knowing we're just scratching the surface. Speaking of which, we've covered so much. But before we wrap up, I want to touch on one last thing. Dr. Chaudhary mentioned open-ended exploration in math.
Yes. That's where things get really exciting. What if we could let AI explore math on its own, discovering things we haven't even imagined?
Sending AI explorers into uncharted territory.
Exactly. It's still early days, but there are some promising approaches, like using AI to generate new conjectures or hypotheses.
So AI becomes a problem poser, not just a problem solver.
Precisely. And it could also help us find hidden meaning in the math we already know, identifying patterns and connections we might have missed.
So it's not just about creating new math, it's also about understanding what we already have in a deeper way.
Exactly. And as AI evolves, I think we'll see even more of this collaboration, machines and humans working together.
But where does that leave human intuition, our creativity? If AI gets good at proving theorems, what role is left for us?
It's a question people have been debating for ages, and I don't think there's one answer. But I do believe human intuition will always be vital. We decide what questions to ask, what problems are worth solving, what makes a proof elegant.
Right, it's about more than just the mechanics of proving something. It's about that human desire to understand. And that's something AI, at least now, doesn't seem to have.
I agree. AI is a tool, a powerful tool. But it's up to us to guide it, to make sure it's used to further our understanding.
Beautifully said. And with that, we've reached the end of this part of our deep dive into AI and math. It's a journey, for sure. And we've talked about AI uncovering new math, but what about helping us understand all the math we already have?
Oh, that's a huge area of potential. Think about all the research published every year.
It's overwhelming. No one can keep up with it all.
Exactly. But AI can help us make sense of it, sifting through papers, finding connections, even highlighting gaps in our understanding.
So it's not just about new math. It's about organizing and making sense of what we already know.
Right. It's like AI can help us see the bigger picture, the structure of it all.
And this connects to another point Dr. Chaudhary made. AI helping us understand the why behind mathematical truths, not just the what.
Yes, going deeper. It's one thing to know a theorem is true, but it's another to understand why.
And AI could offer a new perspective there.
Potentially. By analyzing proofs, finding patterns, AI might reveal those deeper reasons.
It's like uncovering the hidden logic and beauty beneath the surface of an equation.
Exactly. And this could change how we teach and learn math, moving from memorization to true understanding.
Yeah, it'd be incredible to make math more about those aha moments.
Right, sparking that sense of wonder. But as we wrap up, I want to bring us back to the future. What's next for AI and math?
Yeah, where do we go from here?
I think we're at a turning point. AI is going to become even more integrated into how we do math, more collaborations between humans and machines.
Combining our strengths to push the boundaries?
Exactly. Who knows what we'll find? Maybe AI will help us solve those big unsolved problems.
Or maybe it'll lead us to whole new areas of math we haven't even imagined.
The possibilities are endless. It's like we're in the early days of a new scientific revolution.
And we have no idea where it will lead. That's both exciting and a little bit scary, right?
Oh, absolutely. But that's what makes it so thrilling. It's a reminder that there's still so much we don't know, even in math.
It's like AI is showing us that math, just like the universe, is full of mysteries waiting to be uncovered.
I love that. And it's this sense of wonder, this drive to explore that will keep pushing us forward.
Absolutely. It's been a fantastic journey exploring these ideas with you.
The pleasure was all mine. And to everyone listening, don't stop questioning, don't stop exploring, keep pushing those boundaries.
Couldn't have said it better myself. Thanks for joining us on this deep dive into AI and math. We'll see you next time for another adventure into the world of ideas.